looks like having the conference here in DC has hurt us as far as people going back to their offices or trying to beat traffic home. So I'm going to open the floor to questions for our panel. And the microphones are right here on either side of the room.
What's that? There's no questions.
Does anybody have any questions? Jim.
You always count on Mr. Loudermilk.
We can always count on the FBI.
Well, we'll see. And I'm not with the FBI anymore.
Excuse me.
Doggone it. Not questions about the mission space, and not because it's not interesting, because it's, of course, fascinating. But you didn't really talk too much about the technology challenges of child identification per se. I've read the work that Anil Jain has done recently. I have not found a whole lot of other work that addresses specifically the technical challenges with the actual identification of early children. I'm not aware of any repositories of known subject identification. You know, when my children were born, the hospital took some useless impressions of their inked impressions of their feet, and I assume that's true of all of you as well. There's no repository of that. Could you talk a little bit about the technical challenges in the actual identification of the children and gaps you have that industry, academia could do something to address?
Sure. So there are numerous challenges. One of the problems that we have right off the bat is in the seizure. So oftentimes, the first piece to this is really finding the imagery or video that is of an unidentified child. So you know, imagine, kind of to set the stage, imagine you have an office that's received a lead, you know, out there, wherever. They work up that lead, they get a search warrant, they go, they hit the door, they're gonna now seize the digital footprint of at least one individual, if not more than one. And so that's going to include things like their cell phone, their computer, their, you know, getting into even not physical devices anymore, but in today's day and age, their cloud storage accounts, their potentially email accounts, and maybe numerous email accounts, depending on the nature of the activity that got them in the door to, you know, us in the door to begin with. And then there's going to be things like external storage devices, and there's going to be legacy devices. So we're still going into doors where we're finding, you know, in a cabinet or in a box, you know, hundreds of optical discs, right, which are very challenging to go through. But so we've got this complete, and I like to call it, or kind of refer to it as a ball of data, because in the end we end up with this ball of data. And we image that all, and we process that into some forensic application. And one of our biggest challenges right now is how do we quickly figure out in that data ball what is, number one, really relevant, number two, what depicts new victims, and then how do we confirm that quickly? Because unfortunately, the confirmation of that is not necessary with us. It's us having to then get that into the National Center for Missing and Exploited Children. And so one of the things that, the bigger piece of that is, and one of the problems that we have is, when you think about the number of law enforcement agencies that are out there seizing data, and creating these little data balls. So first off, these data balls are all siloed off by and large. They're not cross-aggregated except for in a couple of ways. And so we have micro silos that sit inside of bigger silos that may be based on location. And right now, they're culling the data out. They're basically figuring out what's responsive to the warrant, and then they're sending that into the National Center for Missing and Exploited Children, but we're doing that manually. So most people would be surprised that Federal Express is probably the largest purveyor of the transportation of child pornography in the world, because law enforcement uses FedEx to send those files to NCMEC. And so basically a field office goes onto the, processes the data out, does a cull to separate by and large the wheat from the chaff, takes what is responsive, then puts that into a piece of media with a report or a form, and then they package it up and they FedEx it to the National Center for Missing and Exploited Children. Or, I mean, it could be UPS, it could be the Postal Service, it depends on the agency. But it basically is some shipping mode of transmittal to them. So then once it hits them, the liaison at NCMEC, it gets basically provided over to the National Center because there's some legal implications. Law enforcement has to receive it. Law enforcement has to then kind of keep in control, and it goes back to law enforcement. The National Center then processes it into the repository, and it bugs me, and I've been saying this for a number of years, that it's like, and every year, just change the year. But look, we're in 2017, and we're still FedExing files. And that is a huge technological gap. We refer to this as the $1 million problem, because ideally what we'd like to see is the digital transmission of those files, in a seamless way, but bandwidth, I mean, there's lots of different issues that are there, but we really need a mechanism that is secure, that will pass, because one of the things you look at when you think about law enforcement agencies, particularly a federal agency, as you know, Jim, and some of the requirements that we're under, especially in protecting the data, is we've got to get things through several different checks and balances along the way. So we have to make sure it's compliant with all the CFRs and privacy and all these issues. Then on top of that, we got to get passed through, a chief information system security review, right? Which is, I don't know for you, but for me, is one of my big headaches. Because the minute, I personally think the solution to this problem is cloud-based. I don't think, this is not an issue of us just being able to send that data over the wire in a seamless, never going into any other storage platform. In my opinion, you've got to queue it up into a cloud environment, and it would get sucked down over time as the bandwidth and as the, is allowed. And almost looking at it like how the peer-to-peer file sharing networks kind of aggregate data from different sources to make the downloads faster. I think we have to look at taking advantage of some of those technologies, which means putting this data up in the cloud. Well, when you say to an information systems security officer, I would like to put child pornography up into the cloud, you watch heads explode. That's what happens, boom. And so, because they don't I look at this problem and say, well, to be honest with you, and there are probably people who would shoot me for saying this, but to be honest with you, I think that scenario is likely more secure than the way we're storing that data now in internal systems, which are honestly vulnerable to attack and I mean, so, because that data, doesn't sit locally encrypted because of the amount of time it takes to decrypt, because of other issues. And so we think because it's in our own space, it's super secure, but putting it out to the cloud, we would be looking at encryption like the way we deal with Project Vic right now is a great example. We're using the cloud for pretty much everything related to these images and videos, except for the image and video themselves. We're storing the cryptographic hashes and numerous several versions of cryptographic hashes. We're sending in the data model includes several different what we call robust or fuzzy hashes, so for both image and video. And then we've got all that EXIF data that is, if it's available, that goes along in that data record. So we have this massive data record that includes all of this really contextual information about these files that we're now putting up to the cloud. We have a validation process to validate the user. We have a security certificate that's issued that then, with two-factor security that basically encrypts the data in transmission, and the data is encrypted at rest. When it's downloaded back down, it doesn't get decrypted until it goes through the certificate on the local machine.
So I would think that the actual seized media responsive to the warrant is sitting in your evidence vault anyway. You're
Kind
not
of.
sending that to NCMEC, are
So
you?
kind of. So what happens is we go out and we seize, let's just take one device to keep it simple. So if we go out, we seize your desktop computer, and that has a hard drive in it. What we're going to do is we're going to seize that computer, take it back to the lab, take that computer apart, remove the hard drive, basically, and we're going to image it. We're going to create a forensic image of the drive, which is what we call a gold copy. And the original is going to go in the evidence room, but now that working copy is going to be in the lab to get worked on. So I always have the original evidence. It's always in the evidence room where it should be, but this, what we call derivative evidence or copy, is much less, it's not in an evidence vault. It's not considered original evidence. It is still controlled, but it's something that we're physically working on.
Well, my point with asking that intermediate question was, so you shouldn't have chain of custody issues in transferring it to someone else. Whether you're transferring it in a FedEx truck or a dedicated T3 line or via the cloud, other than protection to make sure that you don't expose it to the public, both to scandalize the public or to assist other pedophiles.
That's
It
right.
should be the only concern.
Chain of custody is definitely not the concern here, because, like I said, this is a copy, and what would go to NCMEC is even a copy of a copy.
So why is that such a problem that it drives the security
So
people crazy? You're not risking the cases.
It isn't. They don't really think in terms of chain of custody. They think in terms of security vulnerability. They think in terms of a hacker gets access to that data in the cloud, and basically DHS is, the headline that scares them is, hacker hacks into DHS repository of child pornography, right? And that headline, that's what makes people's heads
Okay,
explode.
it's the adverse publicity that's the problem.
It's the typical litmus test that a lot of agencies go through. It's the headline test. Would I want this on a headline? And how would, and so my point is, what we have to look at is mitigating risk, right? So we are in a risk business, that's it. In law enforcement and government, we are in an inherently risky, but we do a lot of things that have different levels of risk. I carry a gun. That in itself imparts risk to the agency, depending on how, there's lots of things that could happen there. The same thing with this data, right? There's inherent risk in storing child exploitation data. It's how we mitigate that risk is really the key factor here. And so what I'm trying to argue to these folks is, look, we're never going to make it zero risk, right? What is? Name one thing that we do that's zero risk, right? It doesn't exist. So stop trying to make it zero. Stop trying to say no to something. Let's figure out how we can do it. But it takes the right person. It takes somebody who's progressive. Because when they sign off on it, they now inherit the risk, right? They are a good piece of it. When they say yes, approved, let's put it in the cloud, they inherit risk. So it's a lot easier for them to say, hell no, we're not going to do that, because then we just keep doing the thing. So if 10 hard drives fall out of a FedEx truck and someone finds them and says, hey, that didn't impart any risk to the CISO, because it was a FedEx truck, it's not an IT system.
Right.
I didn't approve that. That was done a decade ago. So that's the issue.
Okay, so transmission is an issue. What else?
Well, Jim, but before you get off of that topic, and Richard chime in if you find the need, we're talking about large files, right? And a lot of large files, so now that complicated the problem on order of magnitude. And we're talking about not just still images, but videos. When we add video to the mix, oh my word, now we're exploding.
Video is really the challenge in that thing. Image is not so bad, but video is really the biggest challenge in that particular gap.
Yep. And isn't it? Policy,
Yeah, I agree with you.
privacy.
I mean, you're exactly right, is streaming, I think that's one of the things that we need to do and probably have not done is look to the streaming technology industry and how they serve that up and, et cetera. I think that is a great point. You're right, Netflix solves that problem, serving up large video files to customers all around the world and other streaming sites.
We kind of looked into, we did kind of look into that, and they use such an advanced network to do that streaming that it's very costly.
Cost prohibitive.
So that was kind of cost prohibitive for us. But this is certainly a topic that's near and dear to us. It's something that since we started Project Vic together, we've been talking about is why are we still stuck in this $1 million problem of not being able to get images and video back to where they need to be, right? Because if they're back where they need to be, that means detectives and we can all run advanced technologies against those images and videos, right? To look at the things that we need to look at. Are there similarities? Are there new technologies that we can run to help us identify? So there's a lot of benefit to having all of these things back to the repository, and we're doing it in a small scale in a way that DHS does have a way to get at least their own stuff back to their home office. But we haven't been able to address at least the 61 separate internet crimes against children task forces that exist around the United States that are, some of them are I call them the haves and the have-nots, right? If you look at the haves, like DHS, FBI, and the bigger agencies, they have the money, they have the resources. But what about that department in Arkansas that happens to have a decent amount of people working on the crime set, but doesn't have the resources to have the huge bandwidth lines in order to accommodate those things?
Yeah. So to address the second question, are there gaps or other areas? One of the difficult challenges we have is, so like right now, we're taking good advantage of cryptographic hash so that we don't have to look at the same file, if it is an exact duplicate more than once. We're taking advantage of things like PhotoDNA or other, kind of p-hashing and other fuzzy hashing to deal with image and video. But like Rich kind of touched on it earlier, that globally around the world, law enforcement categorizes files based on some type of nationwide categorization schema. So here in the US, we have a categorization schema. It's based on federal statutes. Category 1 is illegal by federal definition. Category 2 is indicative, or it depicts a child of illegal material, but wouldn't be in and of itself illegal. Category 3 is what we call CGI animation material that is child exploitation. Or category 0 is non-pertinent. It means it doesn't have any relevance to a child exploitation investigation. Rich also mentioned we have about 3.6 million files that are categories 1, 2, and 3. We also have a 67.5 million set that's non-pertinent. That helps quite a bit, but we have two factors here. So I have a repository just for HSI seizures of 21 million images and videos that I maintain in our lab. Only 3.6 million of that is categorized. The growth on that categorization, well, just the seizure of new unique material into that outgrows the level of our categorization. So we're categorizing slower than we're seizing new material. So we're pushing a boulder uphill. We're never going to push the boulder to the top. And the boulder is eventually going to come down and roll over the top of us. So now with, like Patrick talked about, there is you think back to the Industrial Revolution, and now we're in this kind of machine learning revolution. I think that there is some work that can be done now to try and take advantage of that into working toward auto-classification of that data. Now, it is a difficult problem. Some of the challenges there are, it is very difficult to, in the machine learning and in convolutional neural networks and some of the other deep learning algorithms that are out there, to get the machine to learn context. Humans understand context. So the problem is, I can throw an image that visually look extremely similar. One is illegal, and one is an advertisement for clothing where someone's mostly nude. And the problem is the machine will see those things based on the classifiers as basically very, very similar and throw them into the same bin, whereas a human would very quickly, almost second nature, if they have any experience in categorization files, go, yeah, that's a 1, that's a 0. But machines have a difficult time doing that. And so what I would like to do is close the gap, right? So I think right now the gap is like this, and I do think that we can employ machine learning to close the gap. I don't think we're gonna completely close the gap in my career lifetime, but I do think that we can make it we can definitely close the gap and make it better. So in my opinion, one of the things that, the issue is these problems kind of come up and we've already got funding directed towards certain things, and so now it's a matter of going back and trying to get funding for these things, and you can only go to the paddy well so many times. But one of the things that I see that would revolutionize our work, make things, would have a drastic, global impact, would be, can we use machine learning to say, look, let's train the algorithm to figure out, look, I know that this is something that you absolutely don't care about. I'm confident in that. I understand that this is probably something you do care about, and let's bin it over here. And I'm confident in that. And then there's a bunch of stuff in the middle that I'm not so confident about, and a human needs to review that. I think that is a realistic goal that can be solved with algorithms that are available today. It's just a matter of training and a matter of specifically targeting that problem. The issue that we have is, again, finding the folks, finding the funding, finding the, to get that done. But that's a gap that we have for sure. That's a gap that's a big one. Yeah, go ahead.
I just wanted to add one thing to that. Although, of course, the transmission or the delivery mechanism to get that package, those images and videos, to where they need to be, is a difficult one. But we have made some steps together to try to minimize that or to try to help the situation. And we've worked really close with Thorn on a project that we're kind of proud of. We came up with an idea. We started looking at the problem and said, what are the obligations of law enforcement to send these images and videos? Where do they need to send them? And once the investigators were looking at the same things, right? They were also not only looking at the same things, but they were sending the same things into these repositories. That means there were a very, I won't say the percentage, but it was a very, very high percentage of the materials that were coming into the repositories were duplicates of what they already had. So what we went we started an innovative project with Thorn to look at how can we get our investigators to talk real time with those repositories and shoot an API and says, hey, I'm Detective so-and-so, I have these images and videos, I know I'm obligated to send you these, but I just want to send you these cryptographic hashes of what I am holding right now, and I want you to return an answer, and that answer should be, I already have it, I need it, this is an identified victim, so you should be alerted to that, and start to really communicate earlier on in the investigation so that they're not sending 100% duplicate or 80% duplicates. They're sending what they really actually need to send, and that is the new images, right, that have not been identified, but still checking the box of knowing that they did encounter these other images, because NCMEC has a role where they have to notify victims every time that they've seen one of their images out in the field. So there is a purpose for them to get the images, but do they really need a binary duplicate of the same image? They just need to be notified that that binary duplicate is in that evidence seizure. So we are making some really good inroads with the help of Thorn to thin out, I call it thinning out that package to make it more manageable so that now we can start thinking about the transmission of those packages.
That's wonderful. You know, whenever I think about forensic sciences and these kind of horrific crimes, I'm thinking about the amount of exposure a human being has to put themselves through because they have to view this material time and time again. What can we do as a science community to help the forensic community so that they don't have to expose themselves to this horrific material, not only in categorizing the material, because you heard Jim, it's a small percentage of his material and probably some of the other material at NCMEC and so on that is actually categorized on that 5 scale. But does somebody actually have to sit and look at that and say for each picture and each video how horrific it is and then try to sleep at night? And then if I'm sharing with Kansas or an ICAC somewhere with Jim and his group and so on, do I have to revisit all of that material when somebody in Kansas has already looked at it? What can we do as a community to help the forensic community so that they don't have to subject themselves to this level of horrific material over and over and over again?
Could I just comment briefly? When I was running the National Center, we started this child victim identification program in 2002 because of a bizarre Supreme Court decision that basically held that virtual child pornography is protected speech unless it can be proven that a real child is harmed in the production, that it's protected under the First Amendment. It's not true in the rest of the world, but it is true here. But as a result, we had young analysts, primarily women, who were spending all day, every day, looking at the worst possible content. And we created what we call a safeguard program, using psychologists, using group work, sort of reinforcing. I mean, our concern was we're ruining their lives. We are changing the way they view humanity, particularly male humanity. This is a growing issue. Companies now, because of the obligation to report when they encounter content on their servers, have teams that are reviewing content to determine whether it is actionable, whether they're required to report it. Just a significant lawsuit in one major company by an employee who says, this is destroying me psychologically, it's damaging me, it's affecting my family, it's affecting the way I view the world. So this really is, I realize all I'm doing is buttressing the point that Patty made, but we've got to do something better than simply providing a psychologist to talk to the staff that are tasked with doing this, because to do this work, somebody has got to look at the worst possible content imaginable all day, every day. for long periods of time. And the goal in terms of victim identification, that's why Patrick's work and the work that NIST is doing is so important, is because all we're trying to do is place these children somewhere on planet Earth. You know, the image matching and all of this is simply the beginning of an investigative process. These children are identified and are rescued because of old-fashioned shoe leather investigative work. So the need for new technologies, the need for tools to expedite that and to protect the people who are having to encounter this content all day, every day, is really a massive challenge.
I'm going to switch gears just a little bit and go back to my early days with Jim Cole here. Jim had told me about a case, and what really spawned me on to insist on working on facial recognition on this use case was this particular instance that he had told me about, and that was that there was a school where one of the teachers had been abusing children and proven to have been abusing the children in his classroom. And the parents got together and sued, I believe, the federal government and said, I'll let Jim tell the story. I'm sure he'd tell it much more eloquently than I can. But ultimately, they had to figure out, like, was my kid that was in that class, I don't know, 7 years ago, abused by this person and memorialized in video and or images? Right.
Yeah, so that case, we had a preschool teacher who had been with this school for a number of years in a very affluent neighborhood in a city in the U.S. Where some of the children that were in that preschool or had been in the preschool during his tenure included the mayor of that city, and we're talking about, you know, a large U.S. City. The United States attorney for that district's children had gone through that school, as well as several prominent attorneys in the area and other wealthy business folks, et cetera. And so when the case broke and the individual did a search warrant at his residence and confirmed that he was abusing children from the school, obviously, again, his ball of data was seized, and it was a large, massive ball of data. Immediately, some of these affluent folks reached out to our office and wanted to know, is my child in that ball of data? And is my child a victim? And at the time, this is a number of years ago now, this is in the 2011 timeframe, it was very difficult to answer that question. And the problem is, you know, one of the things that we see in law enforcement is what we've kind of titled the CSI effect, which is folks watch TV and movies, and an unrealistic portrayal of technology is represented in that media, but the public assumes that technology is available to us. And hey, we're Homeland Security, so right off the bat, they think that we have, you know, all of this capability. And so what happened was a couple of the attorneys got together who were parents of children, and they actually petitioned the criminal court, the judge, specifically to force DHS to run facial recognition technology. Of course, they didn't specify what that was or what it meant because they themselves didn't know. But they petitioned the court to force DHS to run facial recognition technology against the data and to have the parents supply school photos of the children and determine if their children were in the data. And I had to write an affidavit in response to that to basically counter that so that the judge did not order us to do that because by and large it wasn't possible. And by and large, the amount of resources and what was available to us at that time would not, you know, and again, the children in these images being abused were of all those issues that Patrick talked about earlier that he summed up with the acronym Peoria. so all those things, pose and illumination and expression, et cetera. So it just wasn't really, we didn't have anything. But that was the catalyst that got us started the dialogue down the road that is really, it's kind of, it's good and bad, I guess, that it's really going to come to fruition really mid-2018. But, it means it's been a 7-year road to get there.
And so, the point is that there are many good uses for this technology. I don't know, if that was my child, I sure as heck would want to know. And we couldn't tell them, or Jim couldn't tell them. So that hurts as well. So there are a number of reasons why we head down the science path, and just figuring out, like, what is your problem, operational person, right? Because unless you live that day in the life, you can't truly understand what their problems are. Many times operational folks can't even fathom that they have a problem until you tell them about some really cool science that will make their job easier. And then they realize, oh my word, I've been living in the Stone Age all this time. And so there are a number of sciences that S&T is embarking on and trying to help this particular use case be more successful, mainly for the forensic analysts and people like Jim, just to identify who that victim is and make it so that they don't have to go through that trove, massive amounts of data using facial recognition to cluster faces together, or camera identification, another thing that we haven't spoken about. But when I don't have the XF data that would tell me the type of camera, the model, serial number, and so on, and I need to know, did this picture and this picture come from the same camera? We're researching and developing and integrating ways of making that a reality, so that folks like Jim and his forensic folks can very easily, when they get that huge cache of data, at least parse it into bins that would help a forensic person make sense of it all. And have I seen this hash before? That's a lot of what Project Vic is doing.
Should we take another question?
Yep, if we have another question. Do we have anybody else that wants to ask a question?
Yes, we have.
Oh, good.
Hello, I got a question. My name is Roger Quint. I work for Ideal Innovations, and we are a facial recognition provider. I have a couple of questions connected. Obviously, from Patrick's report, the legacy facial recognition delivery is not necessarily very useful for the child exploitation task that you all have. So my question is, outside of the auto classification, what would you like facial recognition to deliver if you had to pick one thing that could be improved that would make your practical jobs better? What would that be? Question part one. And part two is, when you are testing or trying different facial recognition algorithms, do you rely fully on NIST, or you have your own platform of practical cases by which you test one versus the other so that you can implement or just see if they work in reality?
So I think the first part of your question is, I guess, how would we use facial recognition to help solve our problem, and what would our kind of number one goal be? Is that right? So as Patty well knows, and Patrick well know, I want what is actually the hardest problem, and that's clustering. What I have is these huge segments of data. So for instance, let's take my 21 million repository and growing. When we implement the FR project that we're working on, and we can actually implement it operationally on that data set, the first thing I want to do is get it to cluster, which means, there's obviously several tasks that go into that. So first it has to do face detection. and it has to do it well, because if you can't detect it, you can't recognize it. So we need the detection and then to cluster like faces together so that all my victims where their faces are present are clustered in the same cluster, my suspects, same thing. Clearly there's going to have to be some human in the loop that does a quality control and a confirmation. But that's really my biggest use case. After that is watch list. I want to take unidentified suspects where I have a face and unidentified victims where I have a face, and watch for new material that were to be introduced to the system that would depict them and then give me an alert. So those are really the two top ones. We have about 5 use cases for FR. To answer the second question, probably in conjunction with Patrick, so yeah, we do rely heavily on NIST. One of the things that we did that maybe we didn't clarify very well is when we have a project called CHEXIA, that's Child Exploitation Imagery Analytics, CHEXIA. And that's, you can find more about that on the NIST website, just nist.gov/CHEXIA. One of the things that we did was in my shop, we ground truthed a very large volume of real world operational image and video. And we ground truthed that by we sat down, we brought in, Patty paid for this, but we brought in 8 special agents from around our offices that are super child exploitation agents, and a research scientist from Pacific Northwest National Laboratory who had a lot of experience ground truthing and annotating data. And we built an annotation tool, we funded and built an annotation tool, and we basically went through well over 100,000 image and video files where we ground truthed that by drawing bounding boxes around every face, every tattoo, and every visual textual item. And so for face, we annotated both eyes, the nose, whether the eyes were open or obscured by like glasses, and then also a quality metric on how difficult that image would be for automated FR on a 1 to 3 scale, male, female, and an age, a bounding age range. And so when NIST is doing the testing of your algorithm, you're really testing it on my operational data. So it's not like they're doing testing on some segregated different data and then reporting out what's it would be the same as if you came into my lab, because that's the same data set we would push you forward because we have ground truth, and that's the only way we can really gauge accurate performance. I'll let Patrick kind of finish that off.
So the questions on testing and what more could be done, right? So Jim's got a number of uses for machine learning that could benefit from work. There's nothing like connecting the experts on development with the data itself. Right now, most face recognition companies, as I said before, are chasing the sort of cooperative market. But certainly some engineers are interested in more relaxed settings, more relaxed constraints. And one area of work is to, if you give a pile of data to a developer, they will go and develop with it. They will go and tune to it. They will go and learn from it. They will look at when the algorithm succeeds and fails. But that's human-in-the-loop development. One promising approach is to have turnkey training built into a face recognition SDK, a product, if you like. Now, this is a bit of a new concept because face recognition historically, pretty much for its entire existence, has worked off the shelf, meaning you get a box of software, you put it on your computer, you run it, and the software is expected to give results, and it does. But it's called the fixed representation. The features that are extracted from a face image are independent of the domain you apply it in, really. It hasn't been tuned to that data set. So we are considering at NIST next year running a challenge problem where we engage anybody, academic, industry, to provide us with software that when applied in a turnkey way, without a PhD sitting down with the data, we train the data on images that it hasn't seen before, and we get better performance than it does natively. So this is turnkey training. The supposition that was articulated to me 2 years ago by somebody very well qualified in the field is that training is black magic. It's a black art. You need a PhD. You need to be a chef in the kitchen. Mere mortal cooks like me can't do this. You need to be Jose Andres. You need to be Thomas Keller, right? Real people can't do cooking like this. And what we want to do is take training out of the hands of PhDs, at least to some extent, tune the representation, and build new face recognition algorithms from the operational data. And Jim made a point earlier that he's got 3.5 million of 21 million, or something like that, categorized. That 3.5 million would be a perfect opportunity for that problem, not face recognition, but categorization. That's ground truth. You've already got the labels, the class labels. That would be easily accessible to somebody versed in machine learning, and particularly deep neural networks. They might need a face detector to do that, or a flesh detector to do that, but they could train it, right? This is part of the, so that is low-hanging fruit. I would consider that to be low-hanging fruit. A whole set of reasons get in the way of why you can't do that, because you can't have people just running around in Jim's facility looking at those images just, without some kind of policy layered on top, right? So, but, yeah, I don't know whether I answered the question or not, but
Excuse me, do we have any more questions?
Anyone else?
Nobody. Now's your chance. Well, I think we've covered a lot of different aspects of this.